Okay. So we're going to start integrals. So previously we have completed gradient, divergence and curl, right? So so first we have started with gradient, and then we have moved on to divergence, and then we have finished curl, and then we have seen vector identities, and then I have given some exercise problems for you, right? So exercise problems is very important. You have to work out all the problems that I have given to you. So the one topic is gradient, divergence and curl. It's a very huge topic, so that I have completed. So now we're going to start the integrals, right? So first we're going to see three integral. The first is line integral, and then surface integral, and then volume integral, and then we'll move on to some well-known theorems, right? So first we will discuss line integral. Line integral is more equivalent to, so in normal integration what we will do, we have integral f of x dx, right? So in place of here our f of x is a single point function. Now here we are going to have f of x is a vector point function. So f of x is a vector point function. That integral is called line integral, right? Yes. So it is more equivalent to the Riemann integration with steady analysis. So first we will define what is meant by Riemann integral, and then we are going to solve some problems based on Riemann integral in this video. So first definition of a line integral. Any integral which is to be evaluated along a curve is called line integral. So we are going to evaluate some function along the curve, right? So it's very easy. First I will put problems, it will be very easy for you. So here it is called f vector dr is called the line integral, right? So f dot dr, it is your convenient, you can either write vector or not, right? So this is called line integral. This is also called as work done, right? So work done is same as line integral, and the integration formula is integral over c f dot dr where dr is equal to dx I vector plus dy j vector plus dz k vector. This is the one formula. Or we can also find f dot dr by using the formula integral over c f dot dr by dt into dt. So these are the two formulas for line integral, right? So integral over c f dot dr, either you can substitute dr to be equal to dx I vector plus dy j vector plus dz k vector, or you can use this formula also, right? So these are the two formulas to find the line integral. So any integral which is to be evaluated along a curve is called line integral. So it is also called as work done. So line integral is also called as work done, and it is equal to integral over c f dot dr. So in order to find work done on line integral, we need to evaluate this integral over c f dot dr, where dr is dx I vector plus dy j vector dz k vector. You can either use this formula or you can also use this formula to evaluate integral over c f dot dr. So first we will move on to the first problem. The first problem is evaluate integral over c f dot dr where f is equal to x square I vector plus y square j vector, and curve C is the arc, and curve C is the arc of parabola y is equal to x square in xy plane from 0, 0 to 1, 1. So first we need to evaluate this integral f dot dr, where f is equal to x square I plus y square j, and it is given that we have to evaluate along the curve y is equal to x square in the xy plane from 0, 0 to 1, 1. So first we need to find integral over C f dot dr. So what they are given, f to be equal to x square I vector plus y square j vector dot dr. So we know dr is dx I vector plus dy j vector plus dz k vector. Now I am going to use only the first formula, you can also use second formula. So when I take a dot product for these two terms, we have integral over C x square dx plus y square dy, and here there is no k vector, therefore 0 into dz is 0. So this is our, we need to evaluate this integral x square dx plus y square dy. Now we need to find the region, right? So they are given that y, we need to evaluate on the curve y is equal to x square. You can either transform all y to x or x to y, right? So I am going to find dy by dx. So what will be my dy by dx? Is equal to 2x. So our dy will be 2x dx. So what I am doing is I am changing y to x. I am changing y to x. So therefore this will be integral. I am changing y to x. So there will be x square dx plus y square. So y square will be x square whole square. Dy will be 2x dx. Now you can see I have changed all to in terms of x. So I can only vary x. So where is x? Our x varies from 0 to 1, right? X varies, okay, we will write here, x varies from 0 to 1. So you have to make this transformation to shift from y to x or x to y. Suppose if you are shifting all x to y, you have to take this limit, again it is also 0 to 1 here, right? So what I am doing is I am changing y to x. So always see which is linear, y is linear. So we change y to x. So that means I am differentiating dy by dx. So I am differentiating with respect to x. So dy by dx is equal to 2x. That means dy is equal to x dx. So I can change dy to be 2x dx and y square to be in terms of x. So we have x square whole square. So I am going to evaluate this over 0 to 1. So that is x is equal to 0 to 1 and just vary x. So this will be x cube by 3, 0 to 1, and here we have, I can take 2 outside, and we have x power 4 into x, that is x power 5. So x power 5 is x power 6 by 6, 0 to 1, right? So I am just integrating this. So we have integral x square is x cube by 3, and here we have x power 4 into 2x. So x power 4 into 2x is, I can take 2 outside, so x power 4 into x, which is x power 5, and integration of x power 5 is x power 6 by 6. So when I apply the limit, we have 1 by 3 plus 2 by 6, right? 1 by 3 plus 2 by 6, and when I take LCM, we will have y dy is equal to 2x dx integral x square dx plus x square, okay, it is y cube. Okay, we will do this for y x square is equal to x square. So this will be 1 by 3 plus 2 by 6. So if I take LCM, we have into 2 into 2. So we have 2 plus 2 by 6, so which is 4 by 6, which is 2 by 3. Therefore 2 by 3 is the integral, right? So what we are doing is we are evaluating this integral. They will give f, and you have to replace dr to be equal to dx I vector plus dy j vector plus dz k vector. To make a dot product, you will have a function of x and function of y. Now with the help of the given curve, you try to change y to x or x to y. If you are changing y to x, that means you are varying x. So if you are varying x, you have to change, you have to take these two x coordinates, that is 0 to 1. If you are taking y, that means it will be 0 to 1, right? Yes. So we move on to the next problem. The next problem is evaluate the next problem is evaluate integral f dot dr where f is equal to x square minus y square I vector plus xyj vector along the curve y is equal to x cube from 0 comma 0 to 2 comma 8. So 0 comma 0 to 2 comma 8. The same problem, we have y is equal to x cube and our function is changed, and you can see it varies from 0 comma 0 to 2 comma 8. So therefore integral over c f dot dr is equal to integral over c. So our f is x square minus y square I vector plus xy j vector into dr is dx I vector, dy j vector, dz k vector. So when I make a dot product, we will have integral over c x square minus y square dx plus xy dy, right? We have no k component here, so therefore dz will be 0. So we need to evaluate this. So again, what I am doing is I am going to changing y to be equal to x cube. That means dy is equal to 3x square dx. So I need to replace. I'm going to transform all to x. So that means I need to vary x is equal to 0 to 2. X varies from 0 to 2. So that means this will be integral 0 to 2 x square minus y. So I am changing y to be x cube. So we have x cube. This will be x power 6, right? X power dx plus x into y. Y is x cube into dy. So dy is 3x square dx, right? 3x square dx. So this will be integral 0 to 2 x square minus x power 6 dx. This will be plus 3 x power 6 dx. So this I can add these two terms. So it will be integral 0 to 2 x square dx. So 3 minus 1 is 2. So this will be integral 2 x power 6 dx. So limit is from 0 to 2. So this will be x cube by 3 integral 0 to 2 plus 2 times x power 7 by 7 0 to 2. Now you apply upper limit minus lower limit. This will be 8 by 3 plus 2 into 2 power 7. So 2 power 7 is 128, I think, divided by 7. So you make some, you take LCM. So we have 256 by 7, 8 by 3. So the answer will be 824 by 21. 824 by 21, right? So only thing is our f is varying here and our c is varying here. It is given that y is equal to x cube. So change all to x. So this will be changing all y to be in terms of x and dy to be in terms of dx and integrate it. So since we are changing all to be x, so just vary x is equal to 0 to 2. So third problem, f is equal to So third problem is evaluate integral over f dot dr 3xy I vector minus y square j vector along y is equal to x square from the x-plane plane from 0 comma 0 to 1 comma 2. So this question asked in IFOS 2006. Right, so we need to evaluate integral f dot dr. That means our f is same problem, right? 3xy I vector minus y square j vector into dr, right? Dr is dx I vector plus dy j vector plus dz. So we have dy is equal to 4x dx. So this will be integral over c 3x. So I am just replacing y again. So y is 2x square into dx minus y square. So it is 2x square whole square into dy. So dy is 4x dx. So I am just varying x, right? So x varies from 0 to 1. x varies from 0 to 1, right? X varies from 0 to 1. So this will be integral 0 to 1. So just evaluate it. So 0 to 1. So it will be 6x cube dx minus, and this will be integral 2 into 4 is 8, x power 4 into x. So x power 5 dx. So we just integrate this. This will be x power 4 by 4 integral 0 to 1 minus 8 x power 6 by 6 0 to 1. So apply upper limit minus lower limit. So we'll get the answer to be equal to is it visible? Is it visible or not? Is it visible now? Okay. So we need to evaluate this integral. So if you evaluate this integral, you will get the answer to be equal to minus 7 by 6, right? So they are given that evaluate integral f dot dr. They are given f, and they are given that we have to evaluate around the curve y is equal to x square in the xy plane from 0, 0 to 1, 2. So we have to evaluate integral f dot dr. So given f to be equal to 3xy I vector minus y square j vector, and dr is dx I vector plus dy j vector plus dz k vector. So when you make a dot product, so you will have 3xy dx minus y square dy. Now I want to change y to be in terms of x, so that means y is equal to x square. So I'm going to dy. I'm going to find dy in terms of dx. So since I'm changing everything to x, so I need to vary x. So we have to vary x from 0 to 1. So substituting all this, so in place of y, I'm substituting 2x square, and in place of dy, I'm substituting 4x dx, and evaluate the integral. You will get the answer to be equal to minus 7 by 6. The fourth problem. So fourth problem is evaluate integral C f dot dr, where f is equal to, fourth problem, where f is equal to x square y square I vector plus yj vector, and C is y square equal to 4x, y square is equal to 4x in the xy plane from 0, 0 to 4, 4. 0, 0 to 4, 4, right? So we need to evaluate integral over C f dot dr. So this is our f is given to be x square y square I vector plus yj vector into dr. So dr is dx I vector, dy j vector, dz k vector. Now this will be integral x square y square dx, x square y square dx plus y dy. Now you can see they are given y square equal to 4x. Now if I try to change y to x, you will have some problem, right? What will you always change linear. So what is linear here? X is linear here. Now you change x to y. In the last previous problem we have y to be linear, that is y is equal to x square, y is equal to something. Now what I am going to do is if you try to change this to dy y to x, we will have 2y dy by dx is equal to 4x, That means 2y dy is equal to 4 dx. So you can replace dy to be 4 by 2y dx. You can see you have y term here again in dx. So for that matter, what we will do is we will try to change x to y. We will change to by x to y. So what we will do is differentiate with respect to x now. Sorry, with respect to y. So this will be 2y and this will be 4 dx by dy. Right, 4 dx by dy. So I am just differentiating with respect to y. In the all previous problem we have y to be linear, so differentiated that with respect to x. Now this will be 4 dx is equal to 2y dy, and I can cancel 2 again. So 2 dx is equal to y dy. Now you can replace all. Now what I am going to do is I am replacing x to be y. So I am varying y. So y will be varies from 0 to 4. So y varies from 0 to 4. Now just substitute here. So this will be integral. I am changing x to be y, right? X to be y. So that means y square is equal to 4x means x is equal to y square by 4. So x square. So x square will be y square by 4 whole square into y square dx. So dx I am finding to be y dy by 2, right? Y dy by 2 plus y dy, right? Limit is from 0 to 4. Now you evaluate this integral, you will get the answer. I'm changing y to x, right? Sorry, x to y. So here we are doing x to y. You can see x is linear, so that's why I am changing x to y. So please do this, right? So this will be y power 4 y square into y. So overall we have y power 7 dy. So we have integration y power 8 by 8. You can take 1 by 2 outside. You apply upper limit minus lower limit. You will get the answer. Just take 2 minutes time to do this. So if you evaluate this, the answer will be 264, right? You will get the answer to be 264. Fifth problem. Fifth problem will be evaluate integral f dot dr. F is equal to x square I vector minus xy j vector from the point from 0, 0 to 1, 1 along the parabola y square is equal to x. solution. So we need to evaluate integral f dot dr. So this will be integral over c. Our f is x square I vector minus xyj vector. So dr is dx I vector, dyj vector, dz k vector. So when I integrate this, or when I make a dot product with this, it will be integral over c x square dx minus xy dy. So here it is given that y square is equal to x. So we change, we will differentiate with respect to y. So this will be 2y and this will be dx by dy. So that means dx is equal to 2y dy. So here this will be integral over. So we are varying. We are changing. We are shifting everything to y. That means we need to vary y. So that means integral 0 to 1. So y varies from 0 to 1. So this will be x square. So x square will be y power 4, right? So that means x is equal to y square means x square will be y power 4. Dx will be 2y dy minus x. So y square y dy. So this will be integral 0 to 1 to y power 5 dy minus y cube dy. So this will be 2 times, this will be y power 6 by 6 0 to 1 minus y power 4 by 4 0 to 1. So this will be 2 by 6 minus 1 by 4. 2 by 6 minus 1 by 4. So when I take the LCM, so this will be 1 by 3. So 1 by 3 minus 1 by 4, which is 1 by 12. Now I'll give you one more problem for exercise for you. The sixth problem. Evaluate integral f dot e. Our f is x square plus y square I vector plus xy j vector from 0, 0 to 3, 9 and y is equal to x square. Now you differentiate with respect to x, right, because y is linear. So differentiate with respect to x and it's vary x. So x will be from 0 to 3 and you change everything to y to x, right. So I think you will do this problem very easily. So y is equal to x square, our function is this, and 0, 0 to 3, 9. So seventh problem. So sixth problem is exercise for you, right. The first 6 problems are same type, right. So they have given f and they have given c, that is either it is equal to y is equal to x square or y is equal to x cube, something, either they will give. Now we are going to model 2. So again we are linear integral, now we are at model 2. So seventh problem, evaluate integral over c f dot dr. Use along the curve x square plus y square is equal to 1, z is equal to 1, the positive direction from 0, 1, 1, 0, 1, to 1, 0, 1, where f is equal to 2x plus yz I vector xz j vector plus xy plus 2z k vector, right. We need to evaluate this over the curve x square plus y square is equal to 1 and z is equal to 1 in the positive direction from 0 to where f is equal to this. Now we need to give more attention to this problem, right. So let us mark this to be a, let us mark this to be equal to b. So we need to evaluate integral a to b f dot dr. This will be integral a to b, f dot dr will be So f is this, dr is dx I vector plus dy j vector plus dz k vector. So when you make a dot product, you will have 2x plus yz dx plus xz dy plus xy plus 2z into dz, right? So f dot dr is nothing but you have to make a dot product of f with dr. We know dr is dx I vector plus dy j vector plus dz k vector. So we need to evaluate a to b. A is 0, 1, 1, b is 1, 0, 1, right? Now you can see in moving from a to b, so we need to move from a to b. So you can see x varies from 0 to 1, x varies from 0 to 1, and y varies from 1 to 0, y varies from 1 to 0, z is same, right? Z is 1, z is 1, z is equal to 1, right? When you are trying to move from a to b, x varies from 0 to 1, y varies from 1 to 0, and z is not varying, that means z is equal to 1, right? Yes. So you can see dx, right? In dx, x varies from 0 to 1, dy, y varies from 1 to 0, and you can see z is not varying, that means dz will be 0, right? So this will be integral. So from a to b, dx, x varies from 0 to 1, and z is always 1, so this will be 2x plus y into 1 dx, right? 2x plus y into 1 dx plus, and dy, y varies from 1 to 0, so y varies from 1 to 0, z is always 1, so we have x dy, and here we have 0 because dz is 0 because z is constant. So we need to evaluate integral 2x plus y 1 dx plus integral 1 to 0 x dy, right? Yes. Now again what we need to do is we need to shift y in terms of x, right? Y in terms of x, and we need to find x in terms of y. We need to find y in terms of x, and we need to find x in terms of y. So it is given that x square plus y square is equal to 1. So that means x square is equal to 1 minus y square, and x is equal to square root of 1 minus y square. So similarly, y square will be 1 minus x square. That means y is equal to square root of 1 minus x square. So this will be integral 0 to 1 2x plus y. So I am changing y. So y is square root of 1 minus x square dx plus integral 1 to 0 x dy. So x is square root of 1 minus y square dy, right? So I think you can integrate this, right? So just integrate this and find, here you will just substitute 0 to 1. So you just replace this as integral 1 minus x square whole power 1 by 2. So just apply x power n formula, x power n plus 1 by n plus 1, and then apply differentiate inside. So you will get the answer to be equal to 1. Right? You will get the answer to be equal to 1. So basic integration, right? You just have to integrate this. So integral 0 to 1 2x plus square root of 1 minus x square dx plus integral square root of 1 minus y square dy. And you can also see that these two, you can see that this is 1 minus x square, and it is from 0 to 1, it is from 1 to 0. So you can see this both will be cancelled, right? We have from property, you can see this is from 1 to 0, this is from 0 to 1, this is from 1 to 0. You can see both are same, right? Here dy, here dx, both are dummy variable. So here we will have some positive number. Suppose if I have 7 here, we will have minus 7 here. If I have 6 here, we will have minus 6 here, right? So without even integrating, we can cancel these two terms, right? Because you can see both are same, 1 minus x square dx, 1 minus y square dy. You will get the same answer in terms of x, in terms of y. After substituting the limit, you will get, if one answer is positive, another will be negative, same magnitude. So therefore this two will get cancelled. So we are only left with 2 times integral x dx. So which is nothing but 2 times x square by 2. So which is nothing but 0 to 1, which is nothing but 1. right? You can see this integral get cancelled. So first split up this integral into two integrals, and you say that this integral and this integral will get vanished because they are of by the property that if one is positive, the another will be negative, because the limits are just the if it is a to b, then it is b to a. So that b answer will be negative of that. So it will be cancelled. So I will give you one more problem for exercise 8th problem. Find the work done. Work done is same as integral f dot dr, right? That is, you need to find the line integral. Find the work done. We are given f to be equal to x square minus y square plus zi vector plus minus 2xy plus y into j vector moves from 0, 0 to 1, 1 along y square is equal to x, right? So you just change, just find differentiate with respect to y here. You change all to x and you vary y, right? Same problem which we did. So work done is same as integral f dot dr. The answer will be minus 2 by 3 for this. So 9th problem. Find the work done. Find the work done. F is equal to 3x square I vector plus 2xz minus y j vector plus k vector along the line joining 0, 0, 0 to 2, 1, 3. So we need to evaluate integral f dot dr. So this will be integral over c 3x square dx plus 2xz minus y dy plus 1 into dz. So we can also do we can do this in two methods. The one which we already done, right? So we will fix a to b. So x varies from 0 to 2 and y varies from 0 to 1. Z varies from 0 to 3. But what the thing is, there is no curve, right? In that problem we have curve x square plus y square is equal to 1. With that curve we have found y and x in terms of x and y. But here we don't have any curve, so that means we need to go for some other method, right? If you have no curve, what you have to do is you have to find the parametric equation. So what is the parametric equation of state? The parametric equation of straight line. So we have 0, 0, 0 as 1 point, 2, 1, 3 as 1 point. Now we find the parametric equation x minus x1 by x2 minus x1, y minus y1 divided by y2 minus y1, z minus z1, z2 minus z1. So this we will have x by 2, y by 1, z by 2. Let us make this equal to t. So we have x is equal to 2t, y is equal to t, z is equal to 2t. Right? So in order to find parametric equation, you have to find x is equal to 2t, y is equal to t, z is equal to 3t is our parametric equation, and you can what you can do is now what you can do is you just substitute x to be equal to 2t, x to be equal to 2t, z to be equal to 2t. Sorry, this is 3 minus 0. This is 3. This is 3t. Right? Now just substitute x to be equal to 2t, And what will be my dx? Dx by dt will be 2, dy by dt will be 1, and dz by dt will be 3. So just replace dx is equal to 2 dt and dy is equal to dt. That means we are finding x, dx, dy, dz in terms of dt, and we have dz is equal to 3 dt. Now therefore this integral will be, so you just change dx to be equal to 2 dt, dy to be equal to dt, dz to be equal to 3 dt, and in place of x 2t, in place of y t, that is equal to 3t, and then you just have to simply integrate. So I think you can do this very easily. So this will be integral c. C is from 0 to 1. Sorry, we need to find c, right? So yes. Now how to find t, right? We need to find the limit, right? That means we need to find t. Now you can see our parametric you can see that we need to find from 0, 0 to 2, 1, 2, 1, 3. So what is our parametric equation? It is 2t, t, 3t. Now if you want to get 0, 0, 0 from 2t, t, 3t, what you have to put? What value you have to put for t in order to get 0, 0, 0? You need to put t is equal to 0, right? And again, for obtaining 2, 1, 3 from 2t, t, 3t, what value you need to put? You need to put t is equal to 1. That means our t varies from 0 to 1, right? So in order to obtain 0, 0, 0 from the parametric equation, for what values of t this is obtained? That means t is equal to 0, and again t is equal to 1. So therefore this entire integral will be changed to integral 0 to 1 3 x square. So x square will be 2t whole square, and dx will be 2 dt plus integral 0 to 1 2xz. So 2 times x is 2t, z is 3t, minus y minus t, dy is dt, plus the third integral integral dz, right? So integral dz is nothing but integral 0 to 1 3 dt. So just you need to integrate, very easy process. So just multiply, we have 6, we have 4 here, so 12, 24 t square dt. When integrate this, we have 24 t cube by 3, apply upper limit and the lower limit, you will get answer to be equal to 16. You will get answer to be equal to 16. So move on 10th problem. Now I think it's a very, very easy problem, right? Just have to integrate this, that's it. Evaluate integral over C f dot dr where f is equal to x y I vector x square plus y square j vector, and this curve C is the arc y is equal to x square minus 4 from 2 to 4 12, right? So we need to evaluate integral f dot dr. So that means we need to evaluate integral xy dx plus x square plus y square dy, right? So dr is dx I vector plus dy j vector plus dz k vector. So when you make a dot product, you will have xy dx plus x square y square dy. So the given y is equal to x square minus 4. So when I differentiate this with respect to, you will differentiate with respect to y, differentiate with respect to y. So this will be 1 and this will be 2x dx by dy and this will be 0. So we have dy is equal to 2x dx. So what we are varying y, right? We are varying y. So y varies from 0 to 12. Y varies from 0 to 12. So this will be integral 0 to 12. So x can be replaced by dy, sorry, x will remain as it is. So y will be x square minus 4 dx plus integral 0 to 1 x square plus y square. So x square plus y square is x square minus 4 whole square into dy. So into dy is 2x dx. So this will be integral 0 to 12 x cube dx minus integral 4x dx plus integral 0 to 12 x square. So when expand this a minus b whole square formula, we have a square plus b square minus 2ab into 2x dx. Right? You just multiply 2x to every term and then integrate and apply upper limit and the lower limit. You will get the answer to be 732. So you don't think that I am doing everything for you. Just a normal integration of x power n. So if you know how to integrate x power n plus 1 by n plus 1, and I'm going to substitute upper limit minus lower limit, and then you're going to take LCM or some simplifications, right? So we have solved 10 problems on line integral. So there are many problems. So you can see that I have received almost 3 to 4 calls now. So I will continue tomorrow, right? So we have 10 problems solved today. So tomorrow morning we will continue the remaining problems, right? So I'll see you tomorrow. Thank you.